Yesterday we were discussed about P series, convergence of P series, etc. Okay, now write a problem. Okay, determine the next problem, very important problem. Determine the rational number representing the decimal number decimal number 0.764 764 etc. The rational number means ഒരു പ്രത്യേക ബന്ധം ഉണ്ടാവും അല്ലെ ഇവിടെ 0.64 0.64 6464 continue this number, that means the rational number. Okay, the number like this 716824321 here there is no termination, so this type of numbers is called irrational number. Okay, we want to this determine rational number, the corresponding the decimal number 0.674 764 764 etc. Okay, this type of questions already you done in your +2 in GP. Okay, that means 0.67 764 764 764 etc. we can write as 764 divided by 10 raised to 3. Here 764 is repeated. So here 764 divided by 10 raised to 3 plus 764 divided by 10 raised to 6. Okay. Then 764 divided by 10 raised to 9 plus etc. we can write like this. 0.764 repeated many times, infinity times. That means we can write as in the form of rational number 764 P by Q form 764 divided by 10 raised to 3 because 764 is continuing. So here take 764 divided by 10 raised to 3 as common. So here 1, here 76 raised to 64 by 10 raised to 6. 764 divided by 10 raised to 3 outside എടുത്തു കഴിഞ്ഞാൽ ബാക്കി 1 raised to 10 raised to 3. From here, you take outside 764 divided by 10 raised to 3. That means 1 by 10 raised to 6 plus etc. Okay. Here, R is what? This is a GP. Okay, here R is 1 by 10 raised to 3 divided by 1. That means 1 by 10 raised to 3. Okay. R less than 1. So it is converged by theorem. Okay. So sum is equal to what equation? Sum is equal to A by 1 minus R. In the case of infinity series, this is a infinity series. So we use A by 1 minus R. Here A is what? 764 divided by 10 raised to 3. 764 divided by 10 raised to 3 divided by 1 minus R. R is 1 by 10 raised to 3. That means 764 divided by 10 raised to 3 all divided by 10 raised to 3 minus 1 by 10 raised to 3 is equal to 764 divided by 10 raised to 3 into 10 raised to 3 divided by 10 raised to 3 minus 1. These are cancelled. That means 764 divided by 10 raised to 3 means 1000 minus 1, 9. And important problem. Okay. Write a problem as a homework. Find the rational representation of the same type of problem. Representation decimal number point 412, 412, 412, etc. using series. Using series. Okay. Then convergence test. Convergence test. Let An and B series. Let summation n and bn be series with non-negative terms and suppose that n less than or equal to bn. These are two series, n and bn are two series with n less than or equal to bn. Okay. ഒന്നാമത്തത്, if the bigger series bn, bigger series bn converges, then the smaller series also converges and also converges. Very, very important result. If the smaller series, if the smaller series n diverges, then bn, summation bn also diverges. Okay, n less than or equal to bn is given. N less than or equal to bn. That means all terms in bn is greater than n. Okay. This means a1 less than b1, a2 less than b2. Okay. This type of series is given. Okay. If bn converges, that means this is bigger. This bigger series is convergent. Then the smaller series n also convergent. If the smaller series n diverges, then the bigger series bn also diverges. Okay. Okay. For example, take question. Examine the convergence of simple section. Easy section. Examine the convergence of summation k equal to 1 to infinity 1 by 2k square plus k. Examine the convergence of this series. നമ്മളിപ്പോൾ കൺസിഡർ ചെയ്ത 1 by 5 എടുക്കാന്ന് വിചാരിക്കാം. 1 by 5 plus 2 എടുത്തു കഴിഞ്ഞാൽ ഇതാണ് വലുതുണ്ടാകുക, ഇതാണ് വലുതാകുക. Which is bigger? When denominator increases, what will happen? The values increase or decrease? 5-ൽ ഒരു ഭാഗം കിട്ടുന്നതാണോ 7-ൽ ഒരു ഭാഗം കിട്ടുന്നതാണോ വലുത്?
ഫൈവിലൊന്ന്
ഓ
5 ഒരു ഭാഗം കിട്ടുന്നു.
എന്നാ കേൾക്കുന്നില്ല. ഹലോ ഹലോ Can you hear me? Hello? Okay. Which is bigger? This is bigger. 1 by 7 less than 1 by 5. When denominator increases, the values decreases. Okay. That means here 1 by 2k square greater than 1 by 2k square plus k. Okay, here 2k square, here the adding 2k square plus k. That means here something is added in denominator than this one. That means this is less and this is greater. Otherwise 1 by 2k square plus k less than 1 by 2k square. That's when we put summation 1 by 2 k square plus k less than 1 by 2 k square. Okay, when this is a p series, 1 by, looking this series 1 by 2 k square. That means we can take outside constant from summation 1 by k square. Here the series is p-type series. That means summation 1 raised to n raised to p type. എന്തായിരുന്നു ഈ സീരീസിന്റെ പ്രത്യേകത? If p greater than 1, the series is convergent. P less than 1, the series is divergent. Okay. The specialty of this series is if p greater than 1, it is convergent. P less than or equal to 1, this series is divergent. Then here p is 2. So here p is 2 greater than 1. So this series is convergent. 1 by 2 k square is convergent. The bigger, here the bigger series is convergent. So the smaller series also convergent. Here the bigger series is summation 1 by 2 k square. The smaller series is this one. So summation 1 by 2 k square plus k is convergent. Using which theorem? This one. If bigger series is converges, then the smaller series also convergent. Using that, first we find the bigger series and the smaller series. Then we make it as a P series type. Okay. Next question. Use the comparison test. Use the comparison test to determine whether the series summation k equal to 1 to infinity 1 by root k minus 1 by 2. Convergent or divergent. Here comparison test using the comparison test. So we want to make a bigger series and a smaller series. Here the denominator is minus 1 by 2. 1 by root k minus 1 by 2. Take a 1 by root k, which is bigger. This is the bigger because this value less than root k minus 1 by 2 is less than root k. When less value comes in denominator, then that value is 1 by that value is bigger. So take a small series 1 by root k. That means, and this is also true for summation also. 1 by root k. That means 1 by k raised to 1 by 2. This is a p series with a p less than 1 by 2 less than 1. That means this is divergent. This series is divergent. So smaller series is divergent. Then if the smaller series is divergent, then bigger series also divergent. Convergence test, this is a comparison test, okay? This is known as comparison test. കമ്പയർ ചെയ്തിട്ട് നമ്മൾ ഡൈവേർജൻ്റ് ആണോ കൺവേർജൻ്റ് ആണോ എന്ന് ചെക്ക് ചെയ്യുന്നത്. Okay, that's the comparison. First one is comparison test. Note here, this is a comparison test. Here, write it like this: comparison test. Let and summation and summation bn are series with non-negative terms. Suppose that n less than or equal to bn type. Okay. Next one is limit comparison test. Limit comparison test. First one is comparison test. Then next one is limit comparison test. Let n and bn be series with positive terms. Let summation n and bn be series with positive terms and suppose that limit n tends to infinity n by bn equal to finite value greater than 0. When the series both converge or diverge together. Very, very important. Next important topic, limit the comparison test. That means N and B series. And find first you should find the limit n tends to infinity n by bn finite value greater than 0. Then the series n and bn converge together or n and bn diverges together. If n converges, as bn converges, n diverges, bn diverges type. Okay, that means converges together, diverges together. If one is convergent, then another automatically converges. If one is diverges, automatically another is also diverges. Okay. Example for this type of test. First, examine the convergence of summation k equal to 1 to infinity 3k cube minus 2k square plus 4 divided by k raised to 7 minus k cube plus 2. Then this type of question is given. First you find an and bn. Okay, that means AK, take AK as given series. That means 3k cube minus 2k square plus 4 by k raised to 7 minus k cube plus 2. Take AK as given series. Okay, then take BK as degree of denominator minus degree of numerator. Okay, that means 1 by k raised to degree of denominator divided by minus number degree of numerator. That means 7 minus 3. Here degree is 3, here degree is 7. 7 minus 3 equal to 4. So BK is taken as 1 by k raised to 4. Okay. Then by theorem, limit n tends to infinity n by bk. That's n by bn. Here ak by bk. Limit k tends to infinity ak by bk is equal to 3k cube minus 2k square plus 4 divided by k raised to 7 minus k cube plus 2 divided by bk. Bk means 1 by k raised to 4. Limit n tends to infinity. Limit n tends to infinity ak by bk. That means limit k tends to infinity 3k cube minus 2k square plus 4 divided by k raised to 7 minus k cube plus 2 into k raised to 4 by 1. K raised to 4 divided by 1. Here limit k tends to infinity. What will we do? Here k cube can be take outside as means 3 minus 2 by k plus 4 by k square by k raised to 7 outside 1 minus 1 by k raised to 4 plus 2 by k raised to 7 into k raised to 4. ഇങ്ങനത്തെ പ്രോബ്ലം വരുവാണെങ്കിൽ നിങ്ങൾ എന്ത് ചെയ്യുക, ഏറ്റവും വലിയ പവറിനെ പുറത്തെടുക്കുക. ഫസ്റ്റ് ടൈം എന്താക്കുക, ആ വലിയ പവറിൻ്റെ ഫസ്റ്റ് കോയിഫിഷ്യൻ്റ് ഒരു നമ്പർ ആക്കുക. ബാക്കി ഡിനോമിനേറ്ററിൽ എന്ത് ചെയ്യുക, കെ വേരിയബിൾസിനെ കൊണ്ടുവരിക. So here k raised to 3, k raised to 4, k raised to 7 cancel. Give the value of k equal to infinity, k tends to infinity, 3 minus 2 by infinity plus 4 by infinity divided by 1 minus 1 by infinity plus 2 by infinity. That means 3 by 1. Finite, this is finite quantity, finite value. And by Bn is finite value, then both converges together. Okay, in the case of p raised to k, p raised to k is, in case of bk equal to 1 by k raised to 4. So summation 1 by k raised to 4. Here p is equal to 4 greater than 1. So this is convergent. Bk is, summation bk is convergent by limit comparison test. AK also convergent by limit comparison test. Test summation AK also converges. Okay, so take next question. Test the convergence of summation k into k plus 3 divided by k plus 1 into k plus 2 into k plus 5, k equal to 1 to infinity. By limiting comparison test, we take n as a given series. N equal to k into k plus 3 divided by k plus 1 into k plus 2 into k plus 5. Okay, bk, bn taken as, sorry, here k variables, so ak. Here bk is equal to ak equal to, here k variable is there, so here ak. Bk is degree of numerator divided by degree of denominator divided minus degree of numerator. Here degree is denominator is 3 because k into k into k. That's the biggest degree. Here 3 minus, here degree is 2. 3 minus 2 is 1. So bk taken as 1 by k raised to 1 degree. This one. Okay. So limit limit k tends to infinity ak by bk equal to k into k plus 3 divided by k plus 1 into k plus 2 into k plus 5 divided by 1 by k. Okay. That means limit k tends to infinity k into k plus 3 divided by k plus 1 into k plus 2 into k plus 5 into k. Here outside as k square. Limit k tends to infinity k square into, here k is already is there. From here take k is outside, so 1 plus 3 by k is there remaining. Here we take k from here, this term, that means 1 plus 1 by k. K from this term, that means 1 plus 2 by k into k from here, that means 1 plus 5 by k into k. Here k cube into 1 plus 3 by k divided by k cube into 1 plus 1 by k 1 by k into 1 plus 2 by k into 1 plus 5 by k. These are cancelled. Limit, take limit k tends to infinity. So here 1 plus 3 by infinity divided by 1 plus 3 1 by infinity into 1 plus 2 by infinity into 1 plus 5 by infinity. So the answer is 1 greater than 0. Okay, here also finite value greater than 0. But here bk taken as 1 by k. Bk equal to, summation bk equal to summation 1 by k. Here the p's value is p equal to 1. So the series is divergent. 1 by n raised to p converges if p greater than 1. So here k raised to 1 is p equal to 1. So the series is diverges. So by limit comparison test, AK also diverges. Okay.